So the next speaker is well-known face for as an organizer. He is Dr. Hamed Rasouli, Sadabad. He's a postdoc in our research center, Firefig, at University of Ulster. Hamed is a senior analytical chemist and material scientist with education in polymers engineering, BSc and master, and environment science PhD. I know Hamed for almost 2 years now, and very hard worker. Sometimes I get email from him at 1 a.m. in the morning, and I say, what this guy is doing? Anyhow, I'll leave it to you, Hamed, and good luck.
Yeah. Thank you very much. It's a pleasure to be here, and thank you very much, Ali, for the nice compliments. So I'll keep going to sending you email, maybe 3 a.m., 4 a.m. after this. Then it's all fine. And today I'm going to share some of the results of our experimental work as a part of Intox Fire project in FireCert, Ulster University, in assessing the movement of the fire-generated toxic chemicals through firefighters' gears. Yeah, I know like this topic was covered in loads of presentations and studies, and also here today there were a lot of like great information in this regard. But what I'm trying to do here is to provide some information from a different perspective. Like this is the molecular chemistry. Then, but as the necessary part of all experimental work, what we need to do first, before just going to the lab and put hands on the glassware, we first need to know what we are going to do. And first, what is the problem? So what is the what problem like we are going to address and we are going to study? So in starting from the very first part of this topic, and as like presented in the earlier presentations today, combustion releases loads of materials. Some of them are hazardous, and those toxic chemicals are generated from everything. Like they can be generated from food, from wood. Sorry, they can be generated from polymers, no matter the natural polymers or synthetic polymers or some types of like blended polymers. So it depends on the conditions and availability of oxygen or the level of progress in the combustion reaction. And also why it is important here, because those toxic chemicals, as everything else in the planet, like they have health impacts. And then those chemicals, like including volatile organic compounds, small molecules, with very low boiling points and evaporate so easily. Polycyclic aromatic hydrocarbons and toxic gases, acids, carbon monoxide, cyanides, particulate matter. But the point is, some of them have acute effects and the other ones have some chronic effects. And those impacts can be like from immediate irritation on the skin, or irritation on the respiration system of the body, or sometimes they are chronic and causing long-term effects, such as carcinogenic effects or mutagenic compounds. Mutagenic compounds are compounds that put pressure on DNA, like to change the genes, like to elevate them. It is not always good. So, but again, what is the relation between all these chemicals to firefighters? In our study was like, because firefighters are chronically exposed to complex mixtures, and it is not always the same, but some of those compounds, some of those chemicals, some of those materials are almost always there for them. And some of these chemicals, that they deposit on the skin, or some of them are inhaled by them, remaining in their body. Some diffuse deep through the lung, then entering to their blood, and then metabolism or metabolical reactions. And some just sit some for a while there and then evaporate later. And again, like because like these health issues and this chronic exposures like put more effect on firefighters compared to at least a majority of the other careers, like related to increased risk of multiple cancers, respiratory conditions, heart like heart problems, skin problems, testicle cancer, prostate cancers, gastrointestinal problems, mesothelioma related problems. And also some of these chemicals can disrupt endocrine system. This is important. Why? Because like as far as I saw in loads of like chemical studies or loads of hazard studies, like regardless of like the studying effects on different genders or affecting like different sectors and all, what they focus is all on cancer or all on the final effect, which is, for example, it causes irritation, it causes cancer, it causes mutagenic effect. But sometimes like this one, some of those materials disrupt the endocrine system, and disruption of those hormones in the body can cause a lot of problems like insomnia or loads of, like, I can list a lot of like horrible words related to this, but I want to say like some of those materials have those type of effects too, which are undermined, not very much studies or not adequately studies. And when we come to the other side, now whatever I told in the previous slide was related to the fire. Okay, fire generates toxic chemicals, fire generates these compounds. Some of those compounds has some effects on the body. But what about on the other side? The only thing keeping firefighters like safe and protects them against those chemicals is supposed to be their PPE. And but as like as many other things, like PPEs are not perfect. And why? Because like the materials used in PPE are primarily designed to provide thermal protection. If I'm not right, please correct me in the questions and discussion part. I'm very like eager to hear some opposite like comments on it. And also, we know that even if those PPEs like materials are all fine, are all good, and are completely protective, let's hypothesize it is 100% protective, but against chemicals. But the size and shape of the like all people, we rarely can find two people those like body size and like shape and figure and even their like behavior in like moving hands or legs or be similar. So these differences makes a lot of differences again in the protection levels. On the other side, like firefighters, PPE is not fully effective in preventing chemical exposure because some of those chemicals can diffuse into we don't know what, we don't know how yet. And some of them, when they like went through the body of the firefighters, they reach the skin on that fire event or on the next events. And then what's happened is like they can adhere and then find their ways to dip into the body and cause whatever I mentioned in the previous slide. So if I wanna like conclude this slide, I wanna say like there is a significant knowledge gap still existing in the diffusion mechanisms of chemicals through this. If we know how they make their way through the skin, how those chemicals make their way to pass through those PPE, then we will suggest some solutions for it. So this is one of the items that we have focused in Intoxfire project, like to shed light, at least if we can solve it, but to give some more insight, some more information related to this. And the second part is like related to the performance of different PPEs against a wide range of chemicals. In Intoxfire project, at the moment, we have focused on the firefighters' gears, as a starting point. So the aim of like our study so far is like to experimental assessment of toxic chemicals transfer through firefighter suit on small scale and on a medium scale. I'll show the setup that at the moment we are using in the next slide. And we have focused on both like qualitative and quantitative studies. Like we first want to know what is there to detect that material because there can be millions of them there, but not all of them like deserve to be focused at the first instance. We need to prioritize them and select some of them, considering the time and the budget and the applicability of those studies. So that's qualitative. After running that qualitative studies and detecting what materials we are focusing on, then we here in Intoxfire project, we are developing methods to measure them. Because it is good to be there if, for example, benzene is there or not, if naphthalene is there or not. It is good to know that in what level it is there. And the other, the second one is simulating the fire conditions by burning selected fuels and exploring and exposing ensemble swatch to the different fire effluent. So in the current presentation, I'm going to share the results of the small-scale laboratory setup. And the third one is to determine the nature and the type of fireground chemicals with a broader scope compared to the one available in the literature. Checking the papers, there are a lot of decent papers, decent studies in different levels, all nice. And I'm getting a lot of information from them as a base of my study, but there is at least one problem with them from my perspective. All of them focused just on common materials. They focused on naphthalene, they focused on only formaldehyde, and then they extended their results to the other molecules. What we are trying here to do is to consider a broader range of chemicals, a broader range of molecules in our studies. To cover the volatile organic compounds, polycyclic aromatic hydrocarbons, water-soluble irritants, and etc. The more is the merrier. And then to compare the performance of various fire suit ensembles. Okay, we know that generally it is quite possible that one sort of ensemble with one sort of polymer used in those or textile works very well, but in different manufacturing processes or in different places, they may not behave similarly. Their performance might be different. So what we consider, today's presentation, we are exactly, I'm sharing the results for four different type of ensembles. 3 are new but different. I'll share in the next slide. And 1 is a retired suit. This is the small scale setup that I'm working with that. And we can see that here, the air is provided, then the fuel is placed there and then in this tray. And then we are, the reason of keeping it in this form and the reason of providing the airflow is to keep the combustion situation, they'll never be safe, but as similar as possible, to then it make us possible to compare the results there. Then what we do, we conduct those generated materials and those steam to the chamber. Sorry, where is the laser point here? Probably I can use it here. Sorry. Yeah, it's better. Yeah, sorry that I didn't use it at the start of this slide. So this is tray. We are burning those fuels here, conducting all those chemicals to this chamber. We call it front chamber or exposed chamber. This is the back chamber. And this is the ensemble which is related to the firefighter's gear. So what we do, we let those chemicals to be generated and then deposited on around, on all those chambers. And then some of them will make their way to diffuse through the ensemble and then find the back chamber. What we do, we need to extract them. I don't want to go through the very much detail about this part, but what we do is generally we consider them in 2 groups. One group are related to non-polar or with low polarity materials, which goes to organic solvents. We extract them to dichloromethane. And then those type of chemicals are analyzed in our lab in FireCert and also university by gas chromatography mass spectroscopy, which this is capable to show the very low negligible concentrations of those chemicals. And the second group is related to water soluble compounds. They are extracted to water. They are more with higher polarities. Then what we do, we are cooperating with King's College London University, and then they are analyzed, those samples are analyzed by liquid chromatography mass spectroscopy. And then these are the photos of the four ensembles that used in this study. SP1, SP2, and SP3 are new, and SP4 is taken from a retired suit. And another important difference here is related to PFAS finish. Like PFAS is one of the words that we hear a lot these days, and there are efforts, there are regulations to remove it or change its shape, or should we get rid of it? So, but what is the alternative, and what the standards say? This is all the questions about that. So we included that part in our study too. The first one is like the PFAS. This is the liner, this is the membrane layer, and this is the outer shell of the ensemble. So focusing onto this middle layer, which is membrane, this one has a, I was gonna say regular PFAS finish as a coating on the membrane. And this one has no PFAS at all on the membrane, but has some other compounds on its outer shell. And this one has PFAS, but in a different form, not as a coat, like it's been used in the textile structure of the polymeric material there. And for the last one, it is like as the SP1, like it is like it contains PFAS as a finish coat on its surface. So before just jumping to the chemistry, just to show the conditions of the experiment. Like if we consider this one as the temperature of the fire, we see like the flame when sometimes it is high, the temperature is high, sometimes the temperature is low and drops and goes down. But what was important for us was this temperature not to reach so high, because we didn't want it to ensembles to be destroyed during our experiments. So what we did, I kept it very close to 100, not more than this. So it was all happened during the designing the chambers for or the small scale setup in the experiments, and this is the back of it. We can see it is quite low. And again, another part of initial results is directly related to this part. If we consider the extracted water phase pH. pH is something that we measure, like the acidity of like water-based solutions or water-based liquids. So if it is lower than 7, it is acidic. If it is lower than 3, it is highly acidic. And if it is higher than 7, majorly more than like 9 to 14, it will be basic. Again, more than 9 is not good for skin, and it is again harmful too. But what we see here, like the pH of the front chamber of all ensembles, as expected, it was 2.5 plus negative 0.1, which is strongly acidic. But 3 new ensembles could keep it like could like inhibit those acidic vapors to pass through it. To somehow, it's a good level, not too high, but not too bad. But for the retired suit, we can see that this is almost similar. So what does it mean? It means that, for example, if you get if the firefighter gets an ensemble which is used and washed and decontaminated, and after using it, they feel some itchy skin, or they may feel some burning, some odd like clues on their skin. It is majorly related to this behavior of their ensemble. And then the other thing which was important was about the relative humidity. What does relative humidity mean? The relative humidity means that like the portion of the humidity, that specific amount of air in a specific temperature can hold inside. When it is near to say, like saturated level or closer to 100%, it means that temperature can, that humidity can make its way through the skin, or at least to like sometimes go in, sometimes come out. So we can see in 3 of ensembles, 2 new and 1 retired one, it was a saturated level. So it means that it let generated humidities pass through it. So why it is important? Because it means that when water comes there, it carries loads of water soluble chemicals with itself through the firefighter's body. And as the results of the qualitative analysis, as I mentioned in the earlier slide, these are all related to the chemicals, which almost there for all fire events. So what we did, we focused on them. We can see here formaldehyde. We hear it a lot, and you can see it in loads of documents. Could pass and could find its way to passing through all ensembles. So sorry, I'm talking about the SP1 here, but in the next slide, you'll see it passed through all of them. Acrolein, which is a very dangerous one, and also it's a possibly carcinogenic one. We will go through it. It couldn't pass, or we couldn't detect it at least. So it's a good news about it. And we see toluene made its way to pass through it. And then for the phenyl benzoic acid, for anthracene, acetonaphthalene, phenanthrene, fluorantine, pyrene, benzoalpha-anthracene, benzoalpha-pyrene, and benzo-K-fluorantine. Sorry for all chemical things. They are all carcinogen. They all are, say, dangerous materials, very harmful for the health if we go through them. Hopefully, it stopped all of them. And this type of large molecules could be stopped by all the studied ensembles, but some made their way. The other one is naphthalene. It could pass through it. And bis-2-ethyl hexylphthalate, it could pass through it too. In the later slides, I'm going to share some more results about these four materials. And for the second ensemble, the situation is almost the same. But also, other than those, what we saw, it was phosphonic acid and quinolin, which were found on the back chamber. So you can see here, we didn't detect it in the front chamber, but it is detected in the back chamber. What does it mean? It means that sometimes that PPE itself can release some of those materials in two ways. Sometimes it catches chemicals in one event and then releases in the other one. And sometimes, no, it itself from its own chemical structure releases it. So this is another thing to be noted there. And for the third one, which was the best one, this is the ensemble which contains PFAS, but not in the regular way, to have just this finish on the surface of the membrane layer. As a part of its textile, two materials pass through it, formaldehyde and bis-2-ethyl hexylphthalate. And finally, for the retired one, as we were expecting, you can see loads of chemicals could make them through it, formaldehyde, toluene, benzoic acid, naphthalene, and bis-2-ethyl hexylphthalate, and then eicosanoic acid and pentadecane could pass through it. Here, just also, if I want to add something here, is benzoic acid, we can find it in food, so it is not toxic at all. But sometimes seeing this type of materials there means that in the high temperature, in that conditions, and in a high temperature saturated level, materials can react to each other, and sometimes they change. They are generated, synthesized, and then they are changed. And sometimes no, they last and stay, and then enter to the body, and then do whatever we don't want them to do. So what we did in the next step, we focused so far on 5 compounds in this presentation. There are a lot of other quantitative analysis, but here today I'm sharing the results for some of them. This is toluene. And this toluene, you see, there's a benzene ring with a with CH3, a methyl group on it. We can see that this is the level of that toluene in the front chamber was detected. And this is the concentration of it in the back chamber. And you can see it reduced it, but to this level. The second one, without PFAS finish at all on its membrane, it couldn't stop it, yeah, but what we see also, the level is even more than the general one. So this is one of the points that if we are removing PFAS from something because of some problems, we should be aware to keep the performance of the PPE the same. Like we don't want to move PFAS because of some problems and then leave the firefighters to some other problems, which PFAS was like protecting them against. And the third one could stop it completely, or we couldn't detect any here. And the first one, which was retire suit, we can see like again, it made its way through it. But if we are going, if I want to share some information about toluene is not classified as a carcinogen to humans. It drops into group 3 in IR monograph number 47. But the EPA also suggests a maximum level of 0.07 ppm in indoor setting. Just want to give you an idea about what these numbers mean. So we see here, like it is close to 6 ppm. We see here it is about 2 ppm, and I'm comparing it with 0.07 ppm here. So that's quite high. And when somebody is in that, it is like exposed to that high level of toluene chronically, regularly, so there will be some problems, definitely. So the major concerns related to toluene is related to neurotoxicity, and also it can create some damage to liver and kidney if in a long-term run. The second material that like we checked here quantitatively was related to naphthalene, and we can see here again, it found its way through all like these three. The retired suit was not good. We can see it here, and the third one could stop it. And the point about naphthalene is classified as a possibly carcinogenic to humans. It drops to group 2B as per like IR's monograph number 82. And naphthalene is the most concerning than toluene because it is more stable. And also when it enters metabolically, it can reach some areas, like it doesn't react with oxygen easily. And that's the reason, like it is more harmful compared to toluene there. And if we see this number and compare it with the levels we can see here, we will notice like how problematic it can be. It doesn't mean that, for example, if I'm exposed to that level of naphthalene, that's it, I got cancer, no. But we're just talking about the probabilities, and when lots of those probable stuff just come simultaneously together, then we need to expect some problems there. And then the third one, like which was which is bis-2-ethylhexylphthalate. It has a long name and it is not easy also, but probably this is one of the reasons that I was so shocked, to be honest, to not seeing it frequently in studies. I saw it in some studies, and they try to like quantify it. They try to like check its effect on the health, but not as much as phenol, not as much as benzene or naphthalene. Every study is just going to naphthalene, but this one was neglected. But why it is important? Before also going through the numbers, I just want to say this material, you can find, this material is a plasticizer in polymers. And it's everywhere. It is on this, on my hand, probably on textile, everywhere you can find it. But what is the problem? It is about the level here. Like we can see the levels are like 150 ppm. And also there is another explanation here. Like it turns to microplastics and becomes unavailable for like for detection by gas like chromatography sometimes. So if I'm like reporting here some numbers, the actual numbers probably are higher than this. This is huge comparing to the previous slide. You see this is 15, 10, 5, and here we jump to 15, 100, 150, and 200. And as we can see here, it made its way through all ensembles, regardless of their condition, regardless of their PFAS is there, PFAS is not there. So this is one of the things probably the manufacturers should consider it, or we'll see. But what is it? It is widely used as a plasticizer, as I mentioned, in PVC and building materials. And it is classified as possibly carcinogenic to humans. And I tried to find some numbers to make a good comparison with the other two, but unfortunately, because it drops on the other group, I couldn't find any like reliable number to report here. And the major concern about this material relates to its strong ability to cause endocrine disruption. So it tends chemically interfere to the body's hormones, and hormones are like regulating whatever we do and metabolic systems of all our bodies. Then the next material was about formaldehyde. You'll see it in lots of other studies too. And this is not good at all because formaldehyde is carcinogenic to human. And you can see like it found its way through all ensembles, but some very low, some very high. This one without PFAS on its surface, but with water repellents on its outer shell, was more successful in keeping it, like in stopping it from diffusing through inside. But the problem is that like talking to people who are wearing this type of ensembles, they say like it is like a like it doesn't let their like the humidity even come outside too. So we can see if we reduce the level of humidity entering inside, this type of water-based materials, like or water-soluble materials, won't find their way through there. And then formaldehyde, as we see, pass through all layers of ensembles. And finally, the last material, I'm here reporting it, we quantified is related to acrolein. Acrolein is probably carcinogenic to humans. It is group 2A, but it was great that all ensembles could stop it. And as a conclusion, like all tested ensembles effectively stop the transfer of large PAHs. These are some of large PAHs, like this is anthracene with 3 cycles, this is pyrene with 4, and we can see benzodiphenanthine that I named it with 5 cycles. And they were all stopped, hopefully, with all studied ensembles. And formaldehyde and bis-2-ethyl hexylphthalate like moved across the layers of studied ensembles while acrolein was stopped. Naphthalene and toluene permeated through the layers of 3 ensembles, regardless one of them. As mentioned, PFAS was in its like texture. And the layers taken from the retire suit allowed the transfer of acidic vapors generated by combustion carried by moisture movement carriers through like water-soluble compounds. And the ensemble itself could be a source of some compounds, such as fluorinated compounds, fire retardants, etc. So, but we need to confirm them by experiment. We have some experiments, we have some results, but like we need to do some more like results there to report it. The starting part of the initial result of our study has been published in Fire Safety Journal just a couple of weeks ago. And please, and also it is the open access, gold open access, and the university paid for it to be openly accessed to everyone. So you can just scan the QR code, please, or just by searching like some keywords like our names or Intaxfire, you'll find it easily on the net or on Intaxfire project's website. Thank you very much for your attention.